Hello, Honors Algebra. Mr. Lawrence here with your flipped lesson for the weekend of January 27th. All right, I don't know if you realize this, but we are almost done with Chapter 8. We have not been in Chapter 8 for a very long time. It's a very short chapter. And the thing we're going to do the next 2 days should be totally review. I would only like to spend one day on them, but I got a feeling you guys got some holes in your learning, so I'm going to help you close those holes. All right, scientific notation. Now look, some of you are already freaked out going, I don't get it. It's simple stuff. Just stop. Calm down. Take a deep breath. It's not a big deal. Now let me just first mention to you that the reason we use scientific notation is that some numbers are so massively, monstrously huge that scientists don't want to deal with them. I mean, think about this. The Earth is I'm not in right mode. 93 million, this is on average, miles from the sun. And that's the closest star. The next closest star is something like 2.3 light years away, which is mind-boggling. It means that if you could travel at the speed of light, it would take 2.3 years to get there. Don't hold me to that number 2.3, but you can look it up. I think it's either Proxima Centauri or Alpha Centauri. It's the next closest star. Look it up, see how far it is. It is an incredibly huge number, and if you were going to talk in miles, that number would be so large, it would be a pain in the pachachka to figure out, to deal with, to even say. So scientists came up with this scientific notation. Okay, and there's just a couple rules that you have to follow. Okay, first rule is that to be in scientific notation, the number will be presented so that it's greater than 0, but less than 10. Okay, so it's going to be between 0, greater than or equal to 1. Excuse me, made a silly mistake there. All right, it's going to be greater than or equal to 1, but less than 10. In other words, you're going to have a single digit, then a decimal point. If you don't have a single digit and then the decimal point, you're not in scientific notation. For example, this number here, 3.28 times 10 to the third power, is in scientific notation. Now, you may not know this, but this number here, 32.8 times 10 to the second power, they are equal to each other. They're equal to each other. They have the same value. But this one is in scientific notation. This one is not. Okay, now the OAA is going to love to do that to you. Identify which number is in scientific notation. Give your answer in scientific notation. Is this in scientific notation? I don't know, scientific notation. Oh, well, they're going to have choices. And they're going to have 4 equivalent numbers. But the decimal point is going to be in a different spot. All right, so you're going to have to make sure that you pick the one with the decimal point after the first non-zero number. Yeah, after the first non-zero number. So in other words, this would not be scientific notation. Nope, because that's got to be greater than or equal to 1 and less than 10. All right, now just by the decimal point doesn't mean you can identify scientific notation. All right, there's another criteria. Scientific notation will always be written, always have times 10 to some power in it. Okay, you notice those examples I put up there, they all said times 10 to a power. Now I know some of you are going, I don't get it. What does that mean? Oh, sure you do get it. Let's say we have the number 5.28 times 10 to the 4th power. What that really means is that this is 5.28 times 10 times 10 times 10 and times 10. And if you touch your calculator to figure out what that equals in standard notation, please go home, boil some pasta, and beat yourself with it. All right, look, this is super duper easy. When I'm multiplying by 10, let's see what happens here. Let's see what happens when I multiply by 10. Let's do 5 times 10. I think almost every single person will know that that's 50. What about 52 times 10? Well, I think everybody would know that that's 520. All right. How about 52 times 100? Well, that's 5, 2, 0, 0. Now, some of you are thinking, oh, I get it. You always just add the number of zeros. That is incorrect. You do not just add the number of zeros. But let's see if we can figure out what's going on here. How about 13.5? 13.5 tenths times 10. What would that be? Try to do that without your calculator. Okay, you should get 135. Okay, if I have 230 and 75 hundredths times 10, well, that's going to end up being 2,307 and 5 tenths. Okay. Now the trick isn't a decimal point. And some of you say, there's not a decimal point in these numbers. Sure there is. There's a decimal point right here. In the 5, there's one in the after 52. There's one right there. You see them clearly. Now look at this. There's 1 0 here, right? 1 0. And if you take this decimal point, let me clone him. One 0, he has to move over one place to the right. Has to get bigger by a factor of 10. Yeah. If I'm going to infinitely clone him. If I look at this one, I have 52. Multiplying by 10, there's 1 0. Shoop. Do a little Scooby-Doo. Say a little Scooby-Doo. Let me give the trail in there for you so you don't lose it. All right. Where's the decimal point on this one? Oh, it's still 52. There's 2 zeros, so I'm going to do 1, 2 Scoopies. Scooby-Dooby-Doo. 1, 2 Scoopies. Okay. This next one, the decimal point starts between the 3 and the 5. There's 1 0. I do 1 Scoopy. See how simple that is? All right. And on this last example here, I have 230. Right. There's 1 0, so I do 1 Scoopy. There we go. There you go. So what would happen if I had a number like this? Let's say I have 5.872 times 10 to the 5th. This is written in scientific notation. I'm going to convert it to standard notation, right? Well, the first thing is I'm going to rewrite this number, give myself a little space, 5.872. And I'm going to put my decimal point in. There he is. And you see this 5 here? 10 to the 5th is 10 times 10 times 10 times 10 times 10, right? So in other words, there's 5 zeros, or 5 factors of 10 being multiplied. So I'm going to Scoopy. Can you tell me how many places? You got it. 5. 1, 2, 3, 4, 5. And it's kind of hard to see, so I'll put the trail in. 1, 2, 3, 4, 5. And I'll bet you know that zeros fill in those empty Scoopies. So my number becomes 587,200. This is the scientific notation number, SciNot as I like to call it. And this is standard notation. They are equivalent to each other. They are the same number. They are just presented differently. Not unlike 1/2 is the same as 5/10. They are equivalent mathematically. All right. What would happen if I had a number like this, 6.38 times 10 to the negative 4th power? Well, let me get my little decimal point friend. Let me infinitely clone him. First thing I'm going to do is copy down to 638. I don't want to put that decimal in there, sorry. And I'll put them in now. I have to Scoopy him 4 places. But now I'm not multiplying by 10 to the 4th. I'm actually dividing. Remember, a negative exponent means to use the stairs. This problem is really this problem. It's really the same 6.38 divided by 10 to the positive fourth. How? I just used the stairs. So since I'm dividing, I'm going to go the opposite direction. I'm going to go 4 Scoopies. So I'm going to go 1, 2, 3, 4. And let me show you that trail. That will go 1, 2, 3, 4. Okay, so I fill in these Scoopies, or these empty Scoopies. Oops, I'm not in right mode, with zeros. So the number in standard notation is 0.000638. Okay, so again, here's the scientific notation number, and this one here is the standard notation. All right, now you can go the other way too. You can go the other way too. Let's take a number like 6,321,000. Okay, that's the standard notation, right? To do the scientific notation, first thing I'm going to do is find the decimal point. Oh, looks like he's right there. All right. Now, to go to scientific notation, remember that first rule, my decimal has to be a number greater than or equal to 1 and less than 10. So I need to Scoopy this decimal point so that I'll get a decimal that's greater than or equal to 1 or less than 10, somewhere in there. In other words, the decimal point will come after the first non-zero digit. So I'm going to Scoopy him 1, 2, 3, 4, 5, 6. The decimal point is going to end up there. Let me put the trail in. 1, 2, 3, 4, 5, 6. So my decimal is going to be this. I'm going to drop those zeros at the end because after the 1, they don't mean anything. I could put a million zeros after there and I wouldn't change the value of the number. I need to multiply by a power of 10. What power of 10 am I going to multiply by? Let's count my Scoopies. 1, 2, 3, 4, 5, 6. 6th power to the 6th power. There you go. What if you had a number like this? A very tiny number. Okay, one more time. Get my decimal point. I know that this decimal point, to go to scientific notation, right now this number is in standard notation. To go to scientific notation, this number will have to go between the 1 and the 4 because it'll give me a decimal that is greater than or equal to 1 or less than 10. The decimal has to go after the first non-zero digit. All right, so 1, 2, 3, 4, 5, 6, 7. And let me put the path in there for you. 1, 2, 3, 4, 5, 6, 7. All right. So my number in scientific notation, 1.45, 1/45 times 10. It's not going to be the 7th power. This decimal was smaller than 1 to begin with, and I Scoopied the opposite way, so it's going to be the -7th power. And just if you think about this part here as division, it's division, right? Because the negative exponent needs to move downstairs. When you divide 1.45 by a 1 followed by a 7 zeros, which I think would be 10 million, it's going to be a really small number, just like my original number was. Okay, I think that's going to be it today. On Monday, I'll expect you to be converting to and from scientific notation. Mr. Lawrence signing out.